All right. So there's been lots of Star Wars references. Myself being a big obsessive video games and movies all my life, and getting to go to Disney last night and going on the Tron light cycle, I'll say greetings programs as my intro. um, so I'm here to talk about logs, and it kind of with the theme of IT and OT convergence. He couldn't be here today, but my colleague Derek Lahus is on the IT side of our company. I'm control systems background. So I went to Penn State for electrical engineering. When I came into Bechtel, I got involved with control system cybersecurity early on in my career as kind of a microcontroller hunter, because we were looking for assets that were applicable to the, control system cybersecurity requirements in different projects. I kind of got involved with just regular control system design and then moved on from there and had an opportunity to join a team that was focused strictly on the OT cybersecurity. So I'll get to the question that's the title of this presentation in a little while, but I'll kind of start with a background of the office that I work in and kind of the genesis of this whole project. So on the left side here, you'll see our old. This is when I came into the project. It was a small lab kind of off of our main office, and they used a demo that had Micrologic's PLC. We used the Raspberry Pi as a man-in-the-middle attack, and kind of showed that you can cause some, process upsets with a small, inexpensive at the time machine. And that was using Modbus as the protocol, so lots of protocol parsers for that. So it was really easy to see what was happening with that traffic. So the we were going through a transition period about 2 years ago. We had a new program manager come in. There was a new push towards an initiative called the Asset Performance Management, which I'll touch on briefly at the end, which kind of pulls in some more process data to do some analysis. But I'm going to talk about our new program director coming in. Wanted to refresh our demo. We have a distributed control system in our lab. And when I say distributed, I don't mean necessarily geographically distributed. I just mean within a facility. Typically, you'll have a larger system, at least with the projects we work on. We have a large distributed control system that is distributed throughout the facility. And that's, something like a Honeywell, Schneider, Emerson, Allen Bradley, or ABB, sorry. So within our lab environment, moving away from just a small PLC to one of these larger systems, we wanted to have a demonstration of cybersecurity capabilities, and with that asset performance management to show, the impacts that could happen to a process like this. The other part of it was, with our existing demo, it's kind of hard to see on the left screenshot, but it was two small little water tanks. We had aquarium pumps, some small level instrumentation. So it wasn't something that you would necessarily see out in an industrial facility. So we also in the transition purchased a trainer skid, and this skid had level instrumentation, flow, pressure, and all instruments and sensors that you would see out in the field. So I'll get kind of a little bit more into the physical process on this slide here. So zooming up on this, you can see it's a small, we call it the Acme water treatment plant. It's a small process that has a water tank in the front and a larger reservoir in the back. There's a pump in the back, variable frequency drives on the side to control the speed. We have a control valve that we use in this process to basically have two different phases. So there's a fill and mix phase. The fill phase, we use that control valve to fill kind of quicker in the beginning. And then as we get up to our high level set point, we slow down. And then the phase 2 starts when you hit that high level set point, and then it drains back down. And, this is a common process that you can see out in the field. We wanted to have something to replicate and to start off with, to say, how can you upset a process like this? What are the different methods? And I'll get into a little bit more of the network that this is part of here. So I laid out our, the equipment that's used in our demonstration and kind of aligned it to the Purdue model. So starting on the right hand side here, we have the level 0. So that's where our Acme water treatment skid is that we just saw. That feeds into a DCS controller at our level 1. So with this, this is where the control logic is pushed, and that's what's taking all of the analog digital signals from the instrumentation on the skid and performing the actions that we program on the system. So the level 3 2, because we're in one small location, kind of combine our 3 and 2 into a site kind of local supervisory network there. This is where, so common to these, to most of these distributed control systems is that you have a tag logic database server. It's where all of your logic sits. You have your different function blocks, points, and the engineering and operator workstations will interact with that server to either download logic to the controller or to do a variety of activities. We also have, this system has virtualized servers, so a lot of our engineering operator workstations are virtualized. And kind of moving up a little bit into, we have a DMZ area where we have IDS sensors, some backup servers, vulnerability scanning, which because we're in a lab environment, we do some testing with that. And then in our site local business network, we have a Splunk instance that we kind of leverage from our IT counterparts. And that's what they're more familiar with, and that's what we're learning on. And we also have Malcolm on there, which is from Idaho National Labs. It's another tool that can do a lot of protocol analysis and network monitoring. So our first challenge was really to develop a cyber attack, and the old demonstration used MicroLogic PLC, used Modbus. It was really, those are both well known. The man in the middle attack was using a Python library called Scapy just to craft a packet to send to the PLC to overwrite a set point. But in our case, with our distributed control system, the first thing we kind of realized and ran into was proprietary protocols. And most distributed control systems will have their own proprietary protocol that is, specific to their system. What we first did, I guess jumping back to our network diagram, is we use Wireshark on our engineering workstations, our tag logic database server. And we use that to kind of take a look at what communication was happening between the controller and those two machines. And what you see on the right is a capture that's showing, there's clear text there. It's kind of hard to see from back there, but essentially it's just a bunch of SQL calls, a lot of different, table joins and things like that. So without specific knowledge of the system and how this protocol functions, it's kind of hard to really analyze what this protocol is doing without spending a lot of engineering hours, or maybe going to look at another tool that possibly already can parse this protocol. But so far, in all the tools we've tested out there, we haven't seen one that really looks at this specific protocol. And we also, looking at possibly doing a replay attack of just replaying some traffic back to the controller. we saw that there was some SMB2 authentication, so it would make it challenging to just replace some traffic, especially trying to think about stealing credentials and things like that. So our new kind of attack approach came about, talking with my IT colleague, Derek. We were looking at different tools that were on the system, and a tool that's common on a lot of these systems is a scripting tool, which can do logic exports, backups. Typically when these systems are integrated first, they'll have, this the scripting tool push out a lot of the logic to various controllers. So we started to look at that, and we found that with that tool, which is on this system, they have a GUI kind of interface, and there's also a command line interface. That's what you're seeing on the right side here. But we found that you can take a logic backup of that of the existing logic that's on a controller. You can plug it into a separate system that's running that same integrated development environment, and modify that logic and basically take it back in. So I'm going to focus primarily on the part where we're changing the control logic itself. There's a lot of good presentations that talk about detecting activity on the network level. This really is talking about host-based indicators. So we made an assumption, especially with our demo, we wanted something that was fairly quick and easy for an audience in front of our system to see what was happening. So we made a assumption that we have already, had an adversary exfiltrate valid logic and craft malicious logic, which gets into, we're coming in also thinking about a lot of systems having just perimeter security, and relying on firewalls. We're coming in from a pathway, and especially as for a local audience, having interaction where someone can take USB and plug in to a workstation. We thought that was impactful for local audiences to go through. So after the USB is inserted, we have the scripting tool, which takes that backup of the logic that we've modified, and then that will download it to the controller. And at that point, the control is then manipulated, and the water tank in the front of that skid will start overflowing water. In our case, it pumps it back into a reservoir because it's a closed loop system. This could be something out in the field. It could be overpressured and cause some significant damage. So I wanted to tie the different steps that we have here to different MITRE attack for ICS techniques. We thought this was really helpful to think about the different steps that are happening in the system. And it kind of helps you think about as you're trying to think how you're going to detect an attack like this, because it's really a malicious use of a legitimate program that's on that system. So starting off with the USB, this is replication through removable media. Our current version of the demo, we have someone plug in and they're clicking on what they think is a fake hotfix installer for the system. So that's where we have some user execution, and that's going to be using a valid engineering account because the person's already logged into that machine. From there, the installer that we have on the system runs this command line interface scripting tool. So that gets the command line interface and scripting techniques, and that will download this logic to the controller. And once you get down to what it's actually doing, it is modifying a high level set point. So it's just pushing that high level set point above the top of the tank. So it's overflowing water. So it's manipulating the control of the logic and causing damage to property. So thinking about how to detect this activity, um, you're sitting at your computer, you're realizing, okay, this is a legitimate tool. We're using proprietary protocols. We've had trouble, making sense of what the protocol is actually doing. Um, and my colleague Derek said, well, does this tool have logs, or does the system have logs that could be useful? And we said, sure, there's logs there. And I know we're at Disney, but I'm a kind of a Nickelodeon kid in the 90s, so I got corrupted a little bit by Ren and Stimpy. So when I hear log, I think, it's log, better than bad, it's good. But we're really talking about, our system logs here. And as we started to look through these logs and see what logs were available, there is a lot of information. And this kind of gets into some of the other presentations talking about, living off the land, like what do you have existing on your system? What can you use to make it useful? Where you're not having to reach out and have additional software to, parse protocols and do things, that you might already have this information on your system itself. So the second challenge really was, when we started to look at the logs on this system, we ran into a couple different issues. So the first issue was when we considered getting these logs back into Splunk in our environment, the logs themselves were stored on this system in a proprietary format as well. So it was a proprietary binary files that were unreadable by a Splunk forwarder. We looked at other tools like NXLog and things like that. The only solution that we saw native to the system was a manual export to a text file. So someone would have to go into each log for each workstation, each server, and manually export a log to a text file. And once you had that text file, then you could, read and push it back to your SIEM. But this is a slow manual process, and the time it takes to download logic to a controller is minutes. And if you're not only doing these backups, every week or so, that you're probably going to miss a lot, as you're going through. So we started to kind of look at our system again and kind of investigate. And if you look into actually how we're looking to pull logs, we want to take logs from the engineering workstation that is pushing these logic changes through the tag database server. So those two machines are really critical, and we're pushing it up to Splunk. And this is where we ran into a little bit of luck with the open source community. So I wanted to credit Andy Robinson here. He has a tool called the AA log, which looks at our specific system logs and can convert that binary file into a standard output that can be streamed into a SIEM tool. So the way that we're running this now is that we have forwarders on the engineering workstations, all the different servers in our system. They're looking at those logs, and the way it works also is it will read log files, set markers, and then just every couple, I think it's every 30 seconds, we'll run this tool as a script with Splunk. So it'll read that standard out, see if there's any new logs. If there are, push it up to Splunk. So looking at how to visualize this, so some of the key things we wanted to think about was, okay, we're downloading logic changes. we wanted to think about when would these logic changes usually happen. So we created a logic or kind of maintenance window where this set of hours during a day where normal hours where an engineer and operator could push logic to the controllers. So that's the one part of it there. We also, through the logs, found that you can detect that if a logic was pushed to the controller through the IDE on the system or outside of that through the scripting tool. So we basically created a dashboard that shows the last time logic was downloaded. If it's not within that maintenance window, you get a little red indication. Also, if it's outside of your development environment, that's also another indication. We have the host that the logic was deployed from. We have the user that was logged in that time, and that we pulled from Windows logs. So we're kind of pulling separate log sources together. And then also we're showing that it shows what logic was modified and what function blocks in that logic were actually modified as well. So it makes the response to this a lot better. Like Jack Burton typically says is, it's all in the reflexes. So you need to be able to have quick reflexes with a situation like this, because when you update your logic, you're going to see immediate results. So if you have a slow manual process to look at these logs, you're really not going to have the reflexive nature to be able to respond to this in a timely manner. We also historize that a little bit on the same dashboard. If you scroll down, you can see a history of basically a summary of everything above, with all of the logic and what logic was downloaded, the different objects that were updated, as well as the users logged in at the time on those particular workstations. So I wanted to talk also briefly I talked about asset performance management a little bit in the front. This is another part of my group are working on an initiative about predictive maintenance and how you can use process data to kind of make better operational decisions in your environment. So these are just some different examples of just what it looks like in Splunk. And the nice thing about this was, the nice thing about this is with everything, our security data and our process data, this APM data coming into one platform, we're able to kind of start looking at it and say, is this upset related to a maintenance issue? Is this related to a cyber incident? We can have all the information in one location and have alerting, in certain situations. So to say, if someone did update the logic and it, fell into those parameters of it was outside the development environment and it was, without that maintenance window, we can push alerts to people to say, hey, you need to take a look at what's going on. So I really wanted to just focus on, pulling all these data sources together really can give you a greater sense of what's happening on your system, and it can give you better situational awareness so you can make smarter decisions. So I kind of breezed through this a little bit, so we have a lot of time here. So I'll take a lot of time here to talk about key takeaways from this. Proprietary protocols in these systems are very challenging. There's lots of vendors and tools out there that talk about coverage of proprietary protocols, and in our experiences, we've seen good and bad. And a lot of times, even if it is covered, you're not really getting a lot of the context you need from the protocol. So you might not get all the data about what logic was loaded, what blocks were modified, was the set point changed, things like that, just due to the nature of how the proprietary protocol works. And that kind of gets into like the network indicators. You might be able to easily see them using traffic analysis tools, but depending on the protocol itself, it might be hard to really analyze. So if you're coming at this from an engineering side, you're taking a look and saying, okay, well, I can see a lot of things happening. I'm not sure exactly what's happening on the system. So these host-based logs are really a key data source, and you should be pulling them out into a tool and using those as, even if you are pulling your network traffic, this is another just source of truth that you can put together to have more context on what's happening. And also really, if you have a large system like this, we should really be asking vendors about, is it, keeping everything proprietary, might have, benefits, or might say security through obscurity, but it really, as we've seen with that open source tool, it's, someone's going to have the time to figure these things out. So really having these capabilities for all types of applications and systems, and being able to easily ingest them into other tools is very important for the security posture of your system. And then I guess a takeaway for vendors would be to get proactive about automating this. And I guess this can apply also to just the ICS security vendors as well. Can your tool ingest this type of logging? Or if it doesn't, can you push this out to, could you build this capability into your product so you can push this out to another tool so that you can kind of capture all of this this data into one location and make better judgments. I also wanted to acknowledge all the contributors on my team. So myself and Derek, worked a lot on the cybersecurity portion of this. And then Sonia, Erica, Ovi, and Ben kind of helped with the process and the logic and in the getting that all put together. So it was really a team effort in grouping our IT colleagues and our OT colleagues and trying to look at how we can work together and get the actionable data to a location and make it useful for operators and different personnel on projects. So with that, to say thank you again. I really appreciate it. I've been coming to SANS events for a long time. I've had training. I'm based up in the Reston, Virginia area, so I've been to the Cyber Defense Initiative a lot to take training, and I've been to the ICS Summit now for the past couple of years. So really appreciate the opportunity to talk about the system and our experience here. And if anybody has any questions, I'd be happy to answer.